right, Algebra 2. Welcome back, guys. Here we go again for another video of notes. We're starting Chapter 6 today. So we're going to be jumping into Section 1. And here we go. All right. So we're talking about polynomials. And in Section 1, there's quite a few terms that you guys are going to need to understand, memorize, write down into your notes. And yeah, let's basically just jump right into it here. Okay, so all of these terms that you see, we got polynomial, not a polynomial. These guys right here, you're going to have to understand the basics. All right, the basics of what a polynomial is. Basically, we're talking about one or more terms that are going to be added or subtracted. And these terms are using variables. Okay, now that's a basic, very easy definition. But I'm not going to lie, this part right here, the not a polynomial, that is really important to understand because you may have something that is simply asking, is this a polynomial or not? Or it may even present, hey, simplify the polynomial, and you go too far in simplifying because you actually are dealing with non-polynomial terms. All right, so everything you see here in this part from right here to right here, this is all about not a polynomial. So anything that fits into that category is actually not a polynomial. Okay, so in other words, exponents with our exponent variables. So what I mean by that is if you have 3 to the power of x, that's an exponent variable. That's not a polynomial. Anything with absolute values is not a polynomial. If you ever have a variable in the denominator, so if it says 3 over x, that's not going to be in that category. Anything with square root variables, okay, so we're talking square root of 3x, that's not going to work. And if you have a fractional exponent, you also could think of this as an exponent that's a decimal, because any decimal could be represented by a fraction. So that fits into the same category. And what I mean by that is if you have x to the power of 1/4, basically any fractional exponent could be rewritten as a square root. And then that goes right back to the whole, oh, well, you can't have square root variables. Okay, so all of those are not polynomials. Some other ones, these are real basic right here when it comes to a monomial, that is one term, a binomial, that is 2 terms, and a trinomial, that is 3 terms. All right, so in the video and in class, you're going to hear me use those phrases: polynomial, monomial, binomial, trinomial. You need to know what all those are. All right, because I'm just going to keep flowing through the lecture, and you have to understand that. All right, the next one, this right here, the degree of a polynomial, you're going to be doing that in this section specifically. So the degree is basically the sum of all the exponents, sum meaning addition. So add up all the exponents from the largest term, or if all you have is a monomial, one term, then you're going to add up all the exponents. And that right here is in this example. Okay, so that's one term, meaning it's a monomial. And you'll notice that I'm talking about the degree right here. So we have a 2 from that 2. We have a 1 from this right here. And we have a 4 from that 4 right there. Add the 2, the 1, the 4. That's going to give you a full degree right here of 7. Okay, now what if you have a full polynomial with 3 terms? That would be a trinomial. So there's 1, 2, 3 terms. Then you're actually looking for which term has the biggest exponent. All right, and in this case, it's going to be this right here, the 4. Okay, so because that term has the biggest exponent, then you would say the degree of the polynomial is 4. Okay. All right, next part here, you're going to want to copy this down, or at the minimum, of course, memorize, have it in your notes, all that. If they ask you to classify a polynomial based upon its degree, then use this chart. All right, so first you're going to figure out what is the degree, and then once you know the degree, then you can name the polynomial, and the names are all going down right here. Okay, So we're going to do that. And the last little part we're talking about here, we're going to review again how to graph these on the calculator. By now, honestly, you should fully know how to use this graphing calculator when in terms of the whole y equals and plugging things into y equals. All right. So if you don't, you need to be asking questions. And if you're not asking questions, then help yourself out by looking at some old videos that I've made or looking up your own YouTube videos. Okay. All right. And then the last piece here, standard polynomials, they go in decreasing exponent order. So start with the biggest exponent, work your way down. And there we go. Okay, let's do some example problems. So we are starting with just find the degree of the monomial. So we're looking at one term. What's the degree? All right, so for A, that's pretty simple. We're just looking at this guy right here. So the degree of A is 3. That's it, all right? There's one term. Look at the exponent. What is it? That's it. And by the way, when you look at the exponent, it's the exponent with the variables. So that leads us in to letter B. I don't see any exponent. All I see is just the number 7. So your degree for B is 0 because there's no variables for me to look at. And if there's no variables, there's no exponent for me to look at. Okay, let's move on to letter C. All right, the 5 in this case doesn't matter at all. So don't worry about that 5. What we care about is the 2 and the 4, and then we add them together. All right, because this is a monomial. Let's go back to that definition of degree for the polynomial. Look at the sum of the largest term, but if it's a monomial, you add all of those exponents together. So I see a 2, a 4, so the degree is 6 for that one. All right. All right, let's move on to number 2. We got multiple things they're asking, none of which are very difficult. So we need to rewrite the polynomial into standard form. Step 1. So find the biggest exponent, put it up front, and then work your way down. All right. So x to the 3rd has the biggest exponent. All right, we took care of that. Then minus 18x squared, because now we're looking at the second biggest exponent. Then plus 2x, that has an exponent of 1, and then minus 5. All right, that has no variable or exponent with it at all. So that's step 1, writing it into standard form. Then what is the lead coefficient? So once you rewrite this and it's in standard form, the lead coefficient is whatever coefficient you have with that first term. Now in this case, the lead coefficient is just a 1. There's nothing there in front of the x to the 3rd power, so it's going to be just a 1. So the lead coefficient equals 1. So we took care of that. Now, what is the degree? All right, look at every single term. And because the polynomial is broken up in this time with multiple terms, which term has the biggest exponent? It's the first term. So always look at that first term. So in this case, we're looking at the 3. So the degree is 3. All right. Number of terms. How many terms do I have? Well, I see 1. That's with the x cubed. Then the 2 is with the 18x squared. The 3rd term is the 2x. And then the 4th term is just that minus 5. So there's 4 terms. All right. Number of terms. There's 4 terms. Now name the polynomial. All right. Name the polynomial is based on the degree. So let's go back up to the chart. All right. We are looking at a degree of 3. So this is going to be a cubic. All right. The degree of 3. This is a cubic. Okay. And that covers everything in that question that they were asking of us. Let's move on to example 3. Add or subtract, and then write this into standard form. All right, this one, because there's an addition sign in between the parentheses, we really don't even need the parentheses, meaning you can just immediately jump in and start simplifying this. So there's an x squared. There's another x squared. The x to the power of 3 has nothing to go with. The 6x has nothing to go with. But the constant values have something to combine with. So standard form means biggest exponent up front. So that's going to be the 16x to the power of 3. And then we're looking at a negative 36 plus 16, giving us a negative 20x to the power of 2. All right, so we took care of that. We took care of that. We took care of that. Then next in line is the plus 6x. All right, so we took care of that. Then we have a negative 11 and a negative 5, giving us a negative 16. Took care of that. Took care of that. Okay, so that's it. That's us using addition, combining like terms, and writing it in to standard form. All right, perfect. Let's move down here. Same style of problem, but in this one we have a subtraction sign in between the parentheses. So you need to distribute that negative into the parentheses, which is now going to give you a negative 15x squared minus 3x plus 2. All right, now let's look at our terms. I see some like terms right here and some like terms right here. Okay, that negative 3x has nothing to go with. It also looks like that 5x to the power of 3 has nothing to go with. Okay, so standard form means put the biggest exponent up front. So 5x to the power of 3, that's done. Now you have a 6 and a negative 15, 6 minus 15, giving you a negative 9x squared. That's done. That's done. All right, now minus 3x, that had nothing to go with. And the last piece, 12 plus 2, giving you a plus 14. Covers that. Everything all taken care of. Perfect descending order, decreasing exponents. There you go. That's the standard form right there. All right, and this last little bit, we're going to be graphing these with the calculator. We're going to do this in class, but those are the 2 problems that I want you to write down. Go ahead and remind me in class, hey, Mr. A, we need to graph these on the graphing calculator just to make sure you are all doing it correctly and your graph will match up with my graph. All right, that's all I got for you guys. That's section 1, chapter 6. We'll see you in the next one.